Alright, let's look at the homework 1.6, 1.7, problem number 2. Alright, so let's solve this exact equation. So we already showed that this is exact equation, and let's try to solve it. Alright, so remember that here, this usually called m, but this is going to be partial derivative of capital F with respect to x. Right? And this part right here is the partial derivative of capital F with respect to y. Right? So we're going to use those to find the capital F. Right? So let's start with the partial with respect to x first. Right? So if you want to find the capital F, right? So all you have to do is we need to integrate this guy here, x plus arctangent of y and with respect to x, because this is a partial with respect to x, right? All right, so we're going to get, this is going to be x squared over 2, right? And plus antiderivative of arctangent of y, since it has nothing to do with x, this is considered to be a constant. So any constant derivative is times x, right? So it's going to be x times arctangent of y, right? Then normally we would put plus some constant c, but since we're talking about the partial derivative with respect to x, if you have a function of y, which is considered to be a constant, so you might have a function of y. So we're going to put the g of y, right? Because g of y is a constant. All right, so we have this much. Then you're going to use the second condition. We know that the partial of capital F with respect to y has to be x plus y over x plus y squared. All right, so let's take the partial. So partial of capital F with respect to y would be, all right, partial of x squared over 2 is going to be 0 because there's no y in it, right? And the x arctangent of y would be, all right, x is just a constant, right? So I put that. And the antiderivative of, the partial derivative of arctangent of y with respect to y is 1 over 1 plus y squared, right? Then derivative of g of y with respect to y would be g prime of y, right? And this is equal to, right? So x plus y over x plus y squared. All right, if you split this into x over 1 plus y squared, and also y over 1 plus y squared, right? Then we can get some condition for g prime. So you can see that we can, let's see, subtract. Maybe I'm going to go down here. I'm going to subtract, right, x over 1 plus y squared from both sides. Then you're going to get g prime of y is equal to, right, so that's gone. So you're going to get the y over 1 plus y squared. All right. Then if you want to find the g, you just have to integrate it. So this is going to give us, so you want to find g of y is going to be equal to integral of y over 1 plus y squared with respect to y. All right. Here's a trick. Since we almost have a g prime over g, so derivative of the denominator would be 2y. We have just have 1y, so I'm going to multiply by 2 and divide by 2, right? So that we're going to have, the integral is going to be 1/2, right? Then you have a natural log of, You don't have to put absolute value because this is already positive, 1 plus y squared. Right? And then plus some constant. I'm going to call it C1. All right? But here's the solution. This is an implicit solution. Right? So here we're going to have, so we have a x squared over 2. Right? Plus, right? X arctangent of y. And the g of y came out to be 1/2 natural log of 1 plus y squared, right? And this is f of x comma y, so we can say this is equal to, right? Let's see, I already used C1, so this is going to be, I'm going to call it C2, all right? But that looks a little bit different from the solution given here. So what you can do is actually you just have to multiply through by 2. Right? Then you get x squared plus 2x arctangent of y plus natural log of 1 plus y squared is equal to 2c2. Right? 2c2 is just going to be a number. There's no point of writing a complicated expression for it. So I'm going to just write it as some constant c. Right? So that's how they got the solution there. Right? That's it. I hope that this was clear.